All right, another good one. This is a good one to practice with. This is all about getting better and better with your algebra skills. So I'm going to rewrite things. Of course, when I rewrite them, I'm going to factor them. And this is a really good question to show you something that you have to keep your eyes out for. When I factor the denominators, I'm going to have x plus 5, x minus 5. I'm going to leave some room here because I'm going to probably be multiplying top and bottom by something right away, although I may not in this question. Okay, we'll see. And then over here, I guess 2x and x. We're going to have to do a little bit of thinking here. I think 5 and 1 with a positive and a negative in those positions would do the trick. Yes or no? Good. And again, I'm not meaning to shirk my responsibilities as a teacher here, but at this point in time, factoring those things should not be the problem you're encountering. Shouldn't be. So if you were to just stop there and look at those factors, your lowest common denominator would be something that has an x plus 5 and an x minus 5, and something that has a 2x minus 1, correct? Okay. I'll tell you right now, if you converted these fractions to that common denominator and then simplified the top, you would end up creating, and maybe some of you did this, a degree 3 polynomial. When you multiply it out, you're going to get x cubed somewhere. And you don't know how to factor x cubed yet. You'll do that next year. So why are we giving you this question? Because when you factor the numerator as well, it turns out that this, well, I just want to make something clear here, everybody. Is this a rational expression? Is that a rational expression? Okay. Can you simplify a rational expression by canceling common factors? Yes. So we can get rid of these two before we put things together. And similarly, this is a single rational expression. Yes, we're going to be adding it to something else, but it's a single rational expression, which means you can cancel factors that are common. I mean, I'm going to walk away from this just for a second and make my point in another way. If I asked you to simplify the following, would you start looking at a common denominator right away, or would you say, well, that first rational expression is 1? I hope you would see that it's 1. There's one factor on the top. It's a big, monstrous factor, but there's a factor on the top that exactly matches the factor on the bottom. Boom, you're left with 1 plus 1, which is 2. I meant to write x there, but it doesn't matter. If I wrote an x, then your answer would be 1 plus x. So the point is, if you can simplify something before you get to work on it, do so. What we have left here, Charlie, is 3 over x minus 5 plus 2x plus 1 over x plus 5. And now you can see your common denominator, your lowest common denominator, is x minus 5, x plus 5. So to convert this fraction to that denominator, we multiply top and bottom by x plus 5. And to convert this one to that denominator, we multiply top and bottom by x minus 5. Again, and I've said this maybe 8 or 10 times between today and tomorrow, or today and yesterday, but you should know, don't multiply out the bottom. Leave the bottom in factored form. So we are going to get on the bottom x plus 5, x minus 5. On the top, we get this stuff, but I want to multiply it out. 3x plus 15 plus, what am I going to have? 2x squared minus 10x plus 1x minus 5. And I'll pause there for a breath. Charlie, are you okay with all of those steps so far?
So we should simplify first before we find the lowest common.
Can you repeat that, please?
Sorry. We should always simplify first so we can find the lowest common denominator.
If you can. If you can. The question was, should we always simplify first if you can? Yes. And before I go on, I do want to make a point. Can I do this? Let's look at the whole thing here, the big picture. Can I do this? Can I cancel the x plus 5 on the top of this with the x plus 5 on the bottom of that? No, because that's not a single rational expression. So just be careful about that advice to simplify or cancel first. You know what this is like? Let me go back to where I was. Whoops. This is like me giving you 8 over 2 plus 12 over 4 and saying simplify that. It's not exactly like it, but you don't look at that and go, well, I have two fractions, so I'm going to get a common denominator and put them together. You would say 8 over 2 is 4, 12 over 4 is 3. You would just say it's 4 plus 3, which is 7, and they're a lot quicker. The problem is, however, bless you, the problem is with numbers. If I were to use a common denominator here of 8 and get 32 plus 24 over 8, which is 56 over 8, which is 7. If it's numbers, you can get there if you don't simplify first. I'm telling you that if you were to use a common denominator here before simplifying, before canceling, you're going to dig yourself into a mathematical hole that's just too deep for you to climb out of at this level. By the way, at later levels, I would still give the same advice. Cancel if you can first. Yeah. Let's finish this off. I still need to bring all this mess together here. What do I have? 2x squared. I have 3x, and 1x is 4x minus 10x is negative 6x. And I have plus 10. Does that look okay, you guys? All right, we can take a 2 out of the top. Now that we've packed it all together, we can take a 2 out of the top and be left with x squared minus 3x plus 5. And that's where the road ends. We can't go any further. X squared minus 3x plus 5 is not factorable. So there's only two factors on the top. 2 is a factor, but 2 is not a factor of the bottom. X squared minus 3x plus 5 is a factor of the top, but it's not a factor of the bottom. And I see you checking in the back. Did we get it right? Okay. Similarly, we have x plus 5 in the denominator, but not the numerator. X minus 5 in the denominator, but not the numerator. Nothing is common to the top and bottom factor-wise, so we're done. Other questions? Yeah, sure.
6F.
Okay. 6F. Now, I had mentioned a little while ago, let me rewrite this first. Wow, no, I won't. because I want to make my point before I go on into the factoring of this. I'm going to leave some room because I'm going to need to multiply top and bottom of these by things, factors, to get a common denominator. Before I factor this, I had mentioned a little while ago that if it's x cubed, you don't know how to factor x cubed. And that's not entirely true. You can factor this expression, even though it has an x cubed, because there's a common factor of x, and when you remove it, then it becomes x squared. So let's take a look at the first denominator. Two numbers that multiply to give -6 and add to give 1 would be +3 and -2. Very simple. Here, I'm going to cut a corner. Cutting corners is like cutting across somebody's lawn. That's where that expression comes from. You're saving a bit of time. I'm just going to rewrite this by factoring the x out up here to get x squared plus 2x minus 3. And then I can see what it's going to factor into. I have my x and I have two binomials. I'm searching for numbers that multiply to give -3 and add to give +2. Would be those. So we would want to, at this point in time, just pause, take a breath, double check all the factoring, and I think it looks okay. So our common denominator, I'm not going to write it down on the side like I normally do. Our common denominator must contain an x plus 3. It has to contain an x minus 2. Now that first fraction is taken care of in terms of, how can I put it? In terms of its contribution to the common denominator. The second denominator has a factor of x, so we need to include x in our common denominator. It has a factor of x plus 3, but we already have the x plus 3. And it has a factor of x minus 1, so we need that. So this is our common denominator. And now I'm just going to look up here at the first fraction and say, I'm missing 2 of those 4 factors in the denominator. I have the x plus 3 and the x minus 2. I need to multiply the top and the bottom by x and x minus 1. For my second one, I have all 3 except for the x minus 2. So I have to multiply top and bottom by x minus 2. Does that clock with you? Does that make sense? Okay. So on the top, multiplying these 3 things out is not a real big chore. 2 times x is 2x. I'm going to multiply 2x by the x minus 1. 2x times x is 2x squared. 2x times -1 is -2x. And over here, I just want to check, was it plus? It was plus. Over here, it's 3x minus 6. And now all we have to do is take that numerator, take this numerator, clean it up, meaning bring these x terms together, ask ourselves if we can factor the result. If we can, then we should, and then when we look at it in factored form, if it does factor, cancel any common factors if we can. It may not be factorable, and even if it is factorable, it may not reduce. What do we have? 2x squared plus x minus 6. The order of all of these factors in the denominator is unimportant. As simple as that is for some of you to decide whether it's factorable or not, I'm a discriminant thinker. I need to look at b squared minus 4ac. That's 25. No, it isn't. It's 49. Think. You do the work. You figure out what b squared minus 4ac is for me, please. But I think it's 49. 49 is a perfect square. If b squared minus 4ac is a perfect square, that means that if you were to set that quadratic equal to 0, you get rational zeros, which means it's factorable. Well, it's got to be 2x and x. Probably 3 and 2 would be my guess. I'm not going to put the 2 with the 2x. I'm going to do that. Because if I put the 2 in here, I create a common factor of 2. What do we have for signs? I want one extra x that's positive. There you go. Just double check. I'm asking you to double check, meaning when you FOIL it out, is it correct? Should be, I think. So it was all, well, it wasn't a waste of time. It wasn't that we got nothing out of factoring it. We're all better people for having factored it. You've learned a little bit more. You've gotten a little bit of extra practice. I'm being a little sarcastic, but I'm being a little serious too. This is the best way to write the answer in factored form. The reason why we didn't really need to factor it is no factors cancel. I was looking hopeful for a second there, but it didn't. Is that okay, Ashira? Okay. Other questions? Charlie? 5F? Certainly. Weird looking question. We have 6xy over a squared b minus 2x over ab squared y plus 1. And look how I wrote the 1. How many of you get my point when I say, look how I wrote the 1? I'm writing it so that I can talk about a numerator over a denominator. So let's go back to what we learned from the question you asked earlier, Charlie. If we can, we should simplify that. Can we? No. There's no common factor to the top and bottom. There's no factors of 6 on the bottom. There are no x's and y's on the bottom. There are no a's or b's on the top. Can we simplify this? No. But we're just double checking. Can I simplify 1 over 1? Well, if you want to divide the top and the bottom of that by 1 and write down what you get, and then look at it and go, wait a minute, I can divide top and bottom by 1 and continue, you get in this infinite loop of writing 1 over 1, hey, feel free. We're going to move on, though, because 1 over 1 is 1 over 1. So now let's build our common denominator, everyone. Our common denominator must contain an a, because there's a factor of a here. It must contain a second factor of a, because in the first denominator there's an a times an a squared. It must contain a b, because in the first denominator there's a b. This denominator now is represented in the common denominator so far. We go to the next one, and the next denominator has a factor of a. So we need an a. We already got one. There are 2 b's as factors in the next denominator, and by 2 b's I don't mean 2 times b, I mean b times b. So we need a factor of b and a second factor of b. When I look at where I'm at in building the denominator, so far I have 1, so I need to put a squared on there to get 2, and I need a y. And the last denominator is 1. Well, we already have factors of 1 are always there. We don't need to worry about that. There's a 1 here. If you want to put a 1 in front, feel free, but it doesn't change it. So what do I need to multiply this denominator by to get the new one? Well, I have an a squared, I have a b, I need another b and a y. So I multiply the top by b and by y. My second denominator has an a, but I need a squared, so I need to multiply the top and the bottom by another a. It already has a b squared, and that's what I want, and it already has a y, and that's what I want. This, I need to multiply the top and the bottom by the whole shebang. By everything. And now I can put them together. As different as those three denominators look, they are all a squared, b squared, y's. Right? A squared, b times b is b squared y. A times a is a squared, b squared y. They're all the same. So these are all over a squared, b squared y. What do I get? I get 6xy squared b minus 2xa plus a squared b squared y. Is there anything we can factor out? Well, there's no common factor. I mean, there's a 6 and a 2 in the first two terms, but the other term has a coefficient of 1. So there's no common factor as a number. The first two terms have x's, but the last one doesn't. The first and the third term have y's, but the middle one doesn't. Like there's nothing common to all three. And that's it then. That's the answer. Any questions? Any further questions?